A fence 4 feet tall runs parallel to a tall building at a distance of 2 feet from the building as shown in the diagram. So here's a 4 foot tall fence. It's 2 feet from some building. Find the length of the shortest ladder that will reach from the ground over the fence to the wall of the building. So it'll reach over that fence, touch like that. The shortest ladder. So if you're doing a project, you're some official construction company or building some gigantic thing, wouldn't really just do it for a silly little neighborhood fence, but some really big project, you'd need to calculate, and you want to make sure you have the right equipment. You want to calculate the ladder. What size ladder do we need? What's the shortest ladder that's going to work? What size ladder do we need that'll fit over the fence and hit the building, given all this stuff? Well, down here, here's the formula for the length of the ladder in terms of theta. L theta is 4 cos theta, 4 cosecant theta plus 2 secant theta. We did that in another part. We did the setup problem in another part, and we got that formula. Now, this is the conclusion part. Let's find the angle theta in degrees, not radians, that produces the ladder of minimum length, 3 decimals or more. We get that, and then we're going to calculate the length of the shortest ladder. That'll that'll do that. All right. So let me do that. Let's bring it up here. We have here. Let's write it right up here. L of theta equals, I'm just grab it right here, 4 times the cosecant of theta plus 2 secant theta. Now we want to find the angle that produces a ladder of minimum length. We want to minimize that. You know how to minimize things. We take the derivative and set it equal to 0. So now what's the do you remember the derivative of cosecant? It's been a while. Remember here, let me write it somewhere. Here, I'll just remind you. Derivative secant is secant tangent. And then so when you do so you remember all co-functions, their derivative, this is cosecant. The abbreviation is CSC, but it stands for co of secant. So what's here? It's negative. Derivative of all co-functions is negative. Cosine, cosecant, cotangent is always negative. Negative, and then you just do the cos on these guys. Cosecant, cotangent. Do you see that? How it makes it easy to remember? You can just put it in your notes, but it makes it easy to remember. Secant is secant tangent, and then cosecant is cosecant cotangent, but it's negative because all cofunctions are negative. So that's going to become, let me do that. That'll become negative 4 cosecant theta cotangent theta plus, okay, now what about 2 secant theta? Well, that's secant tangent. 2 secant tangent. Okay. And then we're supposed to set that equal to 0, right? Because when the derivative is 0, that's where you find your mins and your maximum. The slope is flat, you find your peaks and your valleys, right? Highest point, lowest point on a roller coaster. That's when the slope is flat. The L prime is the slope. So I'm going to find those peaks and valleys where the derivative is set equal to 0. Where's that derivative equal to 0? Okay, let's bring that down here. This is going to be a little tricky, a little bit of tricky math to solve this. So we have minus 4 cosecant theta cotangent theta plus 2 secant theta tangent theta equals 0. Now, how in the world do we solve that? Well, I'm going to do a couple tricks with you. Just a little trig tricks. Remember what cosecant is? 1 over sine. I'm going to get rid of the theta for the minute just to make things quicker. What is cotan? Do you remember? Let me write these up here. So, here, let me write sine, cosine. Let's do a little trig review. Remember, if you flip sine, you get cosecant. If you flip cosine, you get secant. And if you flip tangent, you get cotan. Remember that? It's just the flip, like the upside down. And then also remember that tangent is sine over cosine, and therefore cotangent is the upside down of that, cosine over sine. So here we go. Here's our little, this is all trig review. All of that's some trig review, some derivatives up top, and then some just plain old trig functions down there. So remembering all that, we go, okay, so this cotangent is going to be cosine. I'm going to take out the things. I'll bring them back in. Just want to make things easy. Cosine over sine plus, and then secant is 1 over cosine, and tangent is sine over cosine. Okay, now why is that so great? Well, because now this is over 1, so we'll go to the top, minus 4 cosine over sine squared. This is 2 over 1. 2 times 1 times sine. This is like minus 4 times 1 times cosine is on the top there. 2 sine over cosine squared is 0. All right, so we've got that. I was hoping for something a little nicer. All right. Um, and those are added together. Let's jump one of these to the other side. And so we'll get 2 sine over, let me do my fractions right here. 2 sine over cosine squared is positive 4 cosine over sine squared, right? I just jump that to the side, change the sign. Okay, now let's go ahead and cross multiply. So I'm going to go diagonal, diagonal. So that's going to be 2 sine cubed is 4 cosine cubed. Oh, see that? Now, what in the world? You might be thinking, this is getting crazy. Yeah, here comes these are all kind of tricks. Here comes a nice little trick. Watch this. I'm going to divide both sides by cosine cubed. Now, why? Because I know this is sine over cosine whole thing cubed, right? And okay, so what? That's tangent, right? That is now tangent. You remember sine over cosine? Remember that from your trig? You gotta kind of know those trig rules. Tangent is sine over cosine. I think, oh, so you made it one trig function. Yeah, we're almost there now. Divide by 2. Boom, bring it over here. Tangent cubed is 4 over 2 is 2. Ah, we are so close. Now what do we do? Raise this to the 1/3 power, cube root, same thing, cancels. So bring back in the theta now. Tangent of theta. Maybe I should do another. I'm kind of squeezing everything in here. Here, let me bring it on down. Yeah, I'm sorry, I'm not doing this very nice. So tangent, cube I thought I was a little closer. And then we do the 1/3 power and the 1/3 power cancels. So tangent of theta is 2 to the 1/3. Okay, now we're trying to find theta, right? What do you do? Can you divide by the tangent? No, 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 no. That doesn't mean multiply. Remember, whenever it's parentheses. Whenever you have a function, just like f of x, right? That doesn't mean f times x or g of x. It doesn't mean g times, it means g of x. It means you plug in, like plugging bread into a toaster to get an output. That's what sine, cosine, tangent, they're functions. That theta is plugged in. It's not multiplied. Those parentheses do not mean multiply. They're the holes in the toaster. They're where you plug in the angle and you take the tangent of the angle and get some answer. Anyway, long story short, you can't divide by the tangent. No, what do? You do inverse tangent. That's why we have inverse trig functions. Whatever you do to one side, you do to the other. That's what cancels it out. So you get theta. Let me make that not such a weird looking theta. Tangent inverse of 2 to the 1/3. That's our angle. Let's go to Desmos. Tangent inverse of 2 to the 1/3. Now it said degree mode. Did you notice that? So I'll go. Oh no, where's tangent inverse? Go to the functions. There's tangent inverse of what? 2 to the power 1/3. There's my answer, but that's radians. Switch to degrees. See the degree radian? Make sure you go back to degrees. There it is. 51.5609. 51.5609. 51.5609. 51.5609 degrees. That's degrees. Is that what they got? Yeah. That many degrees. Make sure you're in degree mode. That was some tricky steps. Now we're not done. One more. Find the so how long is the ladder? So we found the angle. That's the best angle to fit the ladder over the fence and hit the building. But how long is that ladder? Well, then we just take that angle and we plug into the length formula, right? That they gave us in the very beginning, right here. The length of the ladder is that. So I'm going to go, oh, what is it? It's 4 cosecant plus 2 secant. 4 cosecant plus 2 secant. So the length of the ladder is 4 cosecant plus 2 secant of that angle. Just plug in that angle, plug in that angle. So 4 cosecant plus 2 secant, 4 cosecant. So 4, and you just have to, they don't have cosecant, but you can, well, yeah, I'm going to go 4 over sine. You could type in cosecant if you want. Let me show you. You could type it in if you want, but I'm going to go look. That's 4 over sine theta, remember? And that's 2 over cosine theta, and I'll plug into there and into there. Remember that? That's why I gave you this trig review. The sine and cosecant of the flips, cosine secant of the flips, right? So there it is. So it's going to be 4 over sine theta, 2 over cosine theta. 4 over sine theta. So answer plus 2 over cosine of the, I just use the answer button. See that? I'm just using the answer button because we just had the answer, the angle on the previous step. There's 4 over sine theta plus 2 over cosine theta. There it is, 8.3238. 8.3238. 3238. Is that the length of the ladder? There it is. That's how long, that's the shortest ladder that will fit over the fence and hit the building. Amazing that we can calculate that. Some fancy trig involved. That's why I want you to see this one, a little review of trig there. And so there we go. Very practical problem used by many fields.